Okay, so the 18th problem in Leet Code is the foursome. So this is nothing but just like as we the previous problems we used to solve, right? Two sum, three sum, foursome, right? This is foursome. Okay, so basically before actually jumping onto this foursome, let's just quickly revise what was the two sum and three sum, right? So two sum is nothing but, let's say that x plus y is equal to z, right? Like we will be given some target. Basically we'll be given some target, and we used to ask like which of the some will result into this, correct? So what we used to do is, like, basically we used to use this logic: x is equal to z minus y, right? And we used to check, we'll fix this one, and we'll see like if wherever the this character, like, I mean, z minus y lies in that list, we'll pick that index, right? That was about the two sum, correct? Now if we talk about the three sum, right? What used to happen is x plus y plus z is equal to some target, correct? It can be 0 or something else. Okay, now what we used to do is, like, we will be given the list of integers, and among that we will be assuming the first number as a, like, we'll be assuming one value as a this one. Okay, and now as we know this, we will be trying out the combination on these two, like we as we know the first value, and we will use to set our pointer here, and we used to set our pointer here, and we used to consider this as y, we used to consider this, and we used to take the combination, like, I mean, we used to do all this combination, and we used to take the sum, and then we will check if this is equal to the target or not, correct? So now in the three sum, if we in this method, right, we can use our three sum, correct? Now what is happening is, let's say that this is a plus b plus c plus d is equal to target. Okay, now as we just saw, right, if we know that if there is a three elements, three variables in the left and one target in the right side, we know how to solve it, correct? So what we'll do now is, we'll do the same thing. Actually, we'll make it that way: b plus c plus d is equal to t minus a. Okay, so now we know, right, how to solve this thing, and target will be given in the code, given in the problem itself. And here, like, when we were okay, we know that we can apply threesome problem here, that is for sure now. Okay, now the target is known, and this is not known, we will be applying the threesome, but we don't know, well, like, to solve the threesome, we know we want to know this value, correct? We want to know the target for sure. So what we'll do is, we will fix a also this time. So initially in the threesome, what we used to do is, we used to iterate from the left, and we used to fix our first thing as a our start one, right? We used to fix that, and we used to make this 2 as a variable. And here this time what we will do is, as we are going to iterate and we need a 4 elements, right, quadruplets, we'll need a 4 elements, we'll fix the first one as a. Okay, and rest we'll know, we don't know b c d, we'll have to find among in the list. For that we'll apply threesome. Okay, so now coming back to the code, right, that's what we need to do, and that's what this explanation is about. And so what we'll do is, first we'll iterate through the list. Okay, we'll iterate through the list, and we need to like, I mean, we need to find the quadruplets, right? We'll need a 4 number. It's not needed to go till the end, right? We just need to, let's say that in the given list 4, right, we'll have to go till here, correct? Let's say that I'm fixing this as my first number, sorry, not even this, I need to stop here actually, right? If I start here, 1 2 3 4, so that I can get these 4 numbers. If I start here, I don't get any number, right? It will be overflowed. So that is a condition here. Okay, and now, and also we need to make sure that we don't run the duplicate iterations. So for example, here I have run the iteration for 2, right? If I run the iteration again, it will be the, like, almost the same result we'll get, right? And also it will be a duplicate thing. So what we'll have to do is, we'll have to make sure that we don't from this index, we need to make sure that if we are not doing the same thing, whatever the index we have and whatever the previous one, it is not the same. Okay, that is what we need to do. And now, right, will be assuming, when doing this problem, we'll be sorting it first, basically, right? Like, sorting will not affect our to use a two pointer algorithm, we need to make sure that the array is sorted. And also, like, when we sort, right, the output won't get like, I mean, won't be affected, right? So that's why we'll sort it first, and then now what will happen is, after sorting, we'll be getting some values, and we'll be fixing the whatever the first value, right? We'll be fixing that as the first value. Okay, we'll be iterating through our list, and we'll be fixing that as the first value, and we'll be sending our index. Instead of, if we send a list also, it will be increasing the time memory and all these things, right? We'll be just sending the index to our recursion, our threesome problem. Okay, threesome function. Okay, and here what we have done is, now we have fixed our a. and we know the target also. So now we will be applying the threesome for this. Whatever if you are good, if you are comfortable with that threesome, right, then it is a rest are same. Like, I mean, this is a solution, and we'll be threesome, and we'll be iterating, we'll be setting our pointers, whatever the index we get, right, we'll be setting our start index actually, and we'll be setting the left and right pointers, and we keep on like, I mean, we'll be checking the sum. If it is equal, then we'll be setting our adjusting our pointers again, left and right pointers. If it is if the total is whatever the total we get, if it is less than our target, we'll increment our left pointer to get the higher values. Like, as we know that array is sorted now, and also to reach to the to go near the threesome target, we'll have to increase our number. So basically how we do that will be, we can do that by increasing the left pointer. And similarly, if you want to decrease the sum, like let's say if the value is greater than whatever the target we are getting, we'll have to reduce our values. How will we reduce? Will by decreasing the right pointer. And we know that as the array is sorted, decreasing the right pointer would help us in getting the low value that might help us in reaching the target. Okay, that's what. And also we need to make sure about adding these conditions. Like, I mean, let's say there is a -1 -1, right? Let's say yeah, for this condition, right, we might get a duplicate results without that condition. We need to make sure that when we do -2, right, we need to, when we increment our pointer, let's say that I did the analysis using this array, okay, and this was my left pointer and this was my right pointer. I should not be repeating the same, right? I should not be using the -1 as the left pointer again, because that will lead to a duplicate answer. So we need to make sure we skip the duplicates here, right? We will skip the duplicates, and that's it. Like, I mean, if you're good with the threesome, the only thing that take away from this problem is how to um, if you're good with the threesome, right, we just need to make sure that about this logic, this part of the logic basically, right, we'll be calling the threesome. But like, I mean, we need to convert that this foursome into threesome. That is this problem about. Yeah, that's it. Thank you.